Hello everyone, welcome to example number 4. In this example, we will learn how to find the slope or draw the slope of a non-linear curve. You might be aware of the problem that for a non-linear curve, the slope at different point is different. Well, what is slope of a given curve? Well, slope is the inclination of a line from the x-axis. So if this is x-axis and this is y-axis and this is some line, so the inclination from the x-axis gives you the slope. The tan theta gives you the slope m of the given curve. So how do we do it manually and what is its value at a given point? So well, on a graph paper, the problem arises that how much inclination we have to take at a given point. For example, for this given curve in purple, what will be the slope at the given points, say this point a1, this blue point, say a1, and this given point a2. So the slope at these two given points is different. So why do we measure the slope? The slope gives us the idea of the rate of change of a given physical quantity. And mathematically, how do we represent it? We represent it in by del y over del x by limit delta x tends to 0. This is how we find slope, and in a simple way this is also written as d over dx of y. The derivative of the function y gives you the slope at a given point, say x equal to small a. So let me tell you the actual problem that arises while finding the slope at a given point for a given curve. As you can see, we can draw this red line from any points on this curve. If I connect the end point of this curve to the starting point of this curve, the slope might be different. And if I connect it to a different point, the slope or the inclination towards the x-axis changes. Similarly, if I draw it here, 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 or here, the slope gradually changes. Or in simple words, what I am trying to indicate here is this: the slope at different points on this curve is different. And to find the slope at a given point on the curve, we need to use the definition given in calculus for a slope, that limit delta x tends to 0 for change in y upon change in x gives you the slope at a given point. So at this given point, what we usually do, at the given point, we try to take the endpoints of this line as close as possible. So the important thing that we need to remember is we were taking the limit of delta x to 0. When delta x tends to 0, that means the difference between two points on the x-axis should be very small as possible. Well, an important question students usually ask is how small do we take the change in x for our definition to be suitable? So you can take delta x as small as possible, as much as it pleases you, because it will only impact the accuracy. The smaller delta x would be, the more accurate will be your answer. So how to do it here? A very simple idea is to take 2 points on the x-axis. So if we want to take delta x very small, we have to make this line smaller. The endpoints of this line must lie very near, and that will give the slope. So the problem is almost solved, and what we have to do on the graph paper? Well, I have magnified this green block here, and this point A1 lies here on the graph paper. Since this is the x-axis, so the change in x, which is delta x, has to be taken here. So we can move one step towards right and one step towards left and draw 2 points, well, y as a function of x will lie here and y as a function of x will lie here. So when we join these 2 points, we will get the slope about the point A1. And we can take any smaller interval. We can take intervals of 2, 4, 6, etc. And that will only decide the accuracy of our results. So if we'll move 2 points on the right and 2 points on the left, we will have these 2 points. Let me take a different color. We will have this point and here this point. So if I'll join these 2 points by a straight line like this, I will again get the slope. And as you can see, there is a slight change in the inclination. This line is less inclined compared to this orange line with respect to the positive x-axis. So this is how you find the slope of a non-linear curve using a graph paper. And then you can make use of this triangle here, delta y and delta x, or in this case the change in temperature, delta capital T and delta small t. Well, this is an example of a cooling curve. So that's all for this lecture. Thank you and have a nice day.